Hi, my name is Nathan Durfee, and I decided to do my presentation on the effects of a carbon fiber shoe insert on athletic performance in collegiate athletes. The purpose of it was to examine the effects of a carbon fiber shoe insert on athletic performance relating to speed and power. So, Victory wants to commercially produce carbon fiber shoe inserts but wants it scientifically backed. So, they kind of looked at old research and found out there was no optimization of the carbon fiber insole. So they produced an algorithm for an optimal insole based on weight, foot size, and sport of that athlete, which I think is really cool. So the participants in the study were 28 male collegiate athletes. They were all D2 football players. The mean age of them were 19.4 years old. They were 178.7 centimeters tall with a standard deviation of 4.5 centimeters, and they weighed 85.9 kilograms with a standard deviation of 6.9 kilograms. So the instruments used was a Power Dash 3X laser timing system, which is in the top right corner, those red bars. A Type 9260 AA force plate, which is that blue force plate on the far right. A Vertec vertical jump training system, or measuring system, which is that red and white and silverish bar in the middle. A portable quattro jump force plate, Type 9290CD, which is in that bottom right corner, the black one. And then the participants were actually also given visceral control, TF, New Balance Athletics. They didn't want different shoes messing with different shoes with different stiffnesses messing with the results at all. So the procedures, the participants filled out a physical questionnaire, and then based on the questionnaire, if they were eligible or not, they had their height, weight, and BP blood pressure recorded, and then they were fitted with insoles. They were fitted with 4 different insoles: a medium, a stiff, extra stiff, and then the optimal stiffness based on their weight and sport and shoe size. So the first test they did a week after their initial height, weight, BP, and questionnaire was filled out. They did vertical testing. It began with a 15 to 20 minute dynamic warm up. The vertical testing was with the Vertex and the force plate, but they didn't use the Vertex as an actual measuring system. They just use it for something for the athletes to reach to. They just used the force plate to calculate the height that they jumped. The testing was a best of 3, and they did a control 4F, which was that medium stiffness, a 5F, which was the stiff, the 6F was the extra stiff, and then the optimal carbon fiber insole. So between each different insole, they had a 5 to 7 minute break, just something to give them a little bit of rest. The other test that they did was a 40. So they did the 40 a week after the vertical testing, exactly a week after. And then all this testing is in groups of 2 to 4, so they're not having all 28 participants coming in at a time. So for the 40s, they had a 15 to 20 minute warm up, and then they were able to have 3 submax tries. And then for the actual testing, they had 2 maximal testing, starting with an auditory signal to go. They had about 2 minutes in between each maximal test to rest and had an active recovery. And here they only used a control group, which was no insole, the medium stiffness, and then the extra stiff, as well as the optimal. And then here again, they had 5 to 7 minutes between each control 4F, 6F, and optimal. The results for the vertical testing. So here I'm focusing on they tested for a bunch of, they tested for a bunch of different things, but here I'm going to only focus on jump height, maximal force, and power. So for jump height, they said it increased by 4.1% between control and optimal. They really didn't worry about the 4F, 5F, or 6F carbon fiber insoles. The whole huge difference was between the control and the optimal. So they said it increased from 62.8 centimeters to 65.4 centimeters, which was a 4.1% increase. For force, it measured in body weight, and then a measurement on the force plate. Here again, they just compared the control and the optimal, and here it was a 2.6% increase, which they said was significant. And then for maximal power, it again had a significant increase from control to optimal of 4.6%, going from 85.7, the standard deviation of 12.1, to 89.6, with a standard deviation of 14.8. The results for the 40. So here, they again tested for a bunch of different things, but I chose to focus on maximal power, the 10-yard split, 20 to 40 split, and then the 40 overall. So for maximal power, they said it had a significant increase again, just between the control and the optimal, of 8.1%. For the 10-yard split, they had a 1.6% decrease in time, which they said was also significant. For the 20, they had a 1.3% decrease in time, which again was significant, they said, from the control to optimal. And then for 40, I thought it was really interesting. For the control to optimal, it was a 5.06, the standard deviation of 0.12, to a 5.05 with a standard deviation of 0.12. And here they said there was no significance. I thought it was interesting that the 10-yard split and then the 20 to 40-yard split were both significant, but the overall speed, overall time, wasn't significant. In conclusion, carbon fiber insoles do increase athletic performance when using the optimal stiffness for that athlete. In the article, it stated that it is speculated that individual differences in technique, as well as length, tension, force velocity, relationships with the calf musculature, may influence the appropriate CF or carbon fiber shoe insert stiffness for each athlete to obtain their maximal performance. This basically says that based on the technique of that runner and then how well they're able to push off with their shoe is going to give them the best. It will give them the best. Which one will give them the best insert? So different athletes run different ways and are able to push off differently, and sometimes with more force, sometimes with less. So they're basically saying sometimes their algorithm doesn't work, and for a certain athlete, it could need a different stiffness. And then my analysis of this. So basically, I kind of said that for this to be even more effective, there should be more participants as well as varied. So I said varied, meaning they should test younger kids as well as older kids, and even they should get some female studies going. And then I also said they needed to make the study more clear. So in the study, it said that there were 3 different carbon fiber insoles that they tested for like vertical testing, but it was actually they're testing 4 different ones because there's the optimal one as well. And for some reason, with both vertical testing and 40-yard testing, they just didn't want to talk about or include the optimal as a carbon fiber insole. And then one other thing I thought would be cool to add was change in direction, saying how well carbon fiber insoles are going to increase or decrease, like change of direction with things such as a 20-yard shuttle or even an L drill.